The repetitive nearest neighbor algorithm is also in 6.4, so let's go ahead and do that. But it is a simple change to the nearest neighbor algorithm. Basically, we will just be running it multiple times repetitively as the name of the algorithm suggested. So pick a starting location for your trip. Same thing. Apply the nearest neighbor algorithm to find the route, calculate the circuit, and then repeat this process starting from every other vertex and calculate each of those costs. So basically, we're just going, in that previous example, let's go ahead and do that for the repetitive nearest neighbor algorithm. Um, we will just have to run this a total of 6 times, once starting from each spot. So we already have one done because we already ran the nearest neighbor algorithm in the previous video, starting from C. So let's say we were to start at A, or B, or etc., and see what difference we would get. So let's go back to the graph creator and work from there. Let's just go to B next, and see what would happen if we ran the nearest neighbor algorithm starting from B. So from B, first step would be to go to C because that's our nearest neighbor algorithm, by definitely the cheapest, the nearest neighbor. Um, so that's not so different now. But now we're going to be at C, which is the difference from starting at C. We would then be at B. But if we're starting at B, now we're going to be at C. C, nearest neighbor from there, it looks like should be F, because A is 11, D is 16, E is 26, F is 10. Yep. Now from F, note here that technically B is the cheapest um, target, but we're not allowed to go to B because we've already been there. We only have 3 new places. That's always going to be a next neighbor. So the next nearest neighbor is going to be D, 13. Then we could either go to A or E. Again, we're going to go to A. Now we have to go to E, and we have to go home. Notice it's a similar solution, but it is different, which is why the nearest neighbor algorithm is not perfect, because when you start at a different location, you may get a different solution. And obviously those are typically going to have different numbers, and one should be better than the other. And if we go ahead and check the net weight of that, it says the sum of all weights here is 66, clearly better result than when we started at C. So let's go ahead and note that on our whiteboard, because we're going to have to do that many more times anyways. So if we were starting, I'll go ahead and do this one in red. I'm going to use colors to try to uh, track my different circuits so that I know what I'm doing on my graph. But that our answer, let me go back to what we got from the graph creator, was B, C, F, D. So B, C, F, D, and then A, E, back to B. And the net weight of that was 60. But of course, make sure that you're adding up every single number along the circuit, including returning back to the home. That's something that I've seen students mess up on a lot. It's just forgetting to return home. But since the goal of these problems is to develop a complete plan to go all the locations and return home, that's something that we don't usually want to forget. And we're still not done because we have to the repetitive nearest neighbor algorithm, we have to start at each point. So we're gonna need to start from A, D, E, and F as well, and see maybe those ones will get us a better answer as well. Who knows? And just for the sake of highlighting it, I guess I can highlight that route on my board here as well, which was because you also want to make sure, does this route actually make sense based on the information that we have, B, C, F. Because I was letting the computer do the math for me, so it's kind of helpful to track that out, make sure it's seeming about right. But yeah, that would be a total of 2 plus 10 is 12, plus 13 is 25. Then we went to A, 32, to E, 32 plus 19 is 51, and then we returned back to B where we started in that case. Uh, plus 15 is 66, yes. So cool, that makes sense. Anyways, one of the obvious problems with doing the repetitive nearest neighbor algorithm by hand is that um, if we're trying to draw out all the circuits and highlight them I've been doing in class, it gets a little messy. So maybe it might be a good idea to erase the solutions or something. But I believe if I erase it on this board, it erases the whole thing. So that's going to be a problem. So I'm not going to do that. Anyways, let's continue. Let's finish up this problem. Um, so, okay, next we want to try to start from, let's just say A. So if we're starting from A, our nearest neighbor would be D. Now from D, our next nearest neighbor would be E. I'm going to speed this up just a little bit. From E, our next nearest neighbor would be B. From B, our next nearest neighbor is definitely going to be C. Now we have to go to F, and we have to go home. And that gives us another solution, which apparently the sum of those weights is 64. Even better. Great. So let's go ahead and note that in our work, because we're going to need to cross-reference all of our solutions at the end and pick the best one. So that one, starting from A, got, let's see, let me, A, D, E, B, C, F. I already forgot it. A, D, A, D, E, B, C, F. A, D, E, B, and return home, which was 64 its net weight. Also better. And now we want to finish by checking D, E, and F, see if any of those are better. Let's go ahead and do that. Okay, so if I start from D, my nearest neighbor will be A. From A, my nearest neighbor will then be C. From C, my next nearest neighbor will be B. From B, my next nearest neighbor will be F. I will then have to go to E and have to go back to D, which is a way better result than the other ones. So starting from D, we got a Hamilton circuit of weight 54. Let's go ahead and note that down. So that was DAC, then BFE. And just to recap that, you can solve Hamilton circuits by just listing the permutations of the letters as well without having to highlight the graph. But I think it's helpful to visualize the process, and it helps us see our nearest neighbors in action as we go. And that had a sum net weight of 54. Cool. That one's looking pretty good. I'm kind of doubtful that we're going to find anything better than that. But let's go ahead and run from E and F and check, because we're not really done with the repetitive algorithm until we fully repeat it. So starting from E, our nearest neighbor would be D, then A. Our next nearest neighbor would then be C. Then we would go to B. We'd have to go to F, and then we would have to go home. And that gives us a circuit of net weight 54. My guess is was exactly the same circuit. Now, highlighting your answers can help you visualize that, but if we went ahead and if you reverse the video, you'll see that the final circuit is actually exactly identical. Now, technically it's not the same because we started at a different location, but it really is the same circuit in the context of these problems because we're traveling along all the same routes, therefore spending the same amount of money. So in this case, it would be the same answers just starting from E. So that would be E, D, A, C, B, ending at E, weight 50. And lastly, but not least, we want to start from F and see what we get. So if we start from F, we are going to go to B first, nearest neighbor. From B, we're going to go to C. From C, we will can't go to F because we've already been there. We're going to go to A. From A, we're going to go to D, then to E, and back to F. And actually, this is the same answer again. And one thing that you'll notice when running the repetitive nearest neighbor algorithm is that you tend to get the same answer a lot, and that's usually indicative of the probably the best answer possible. Now, the repetitive nearest neighbor algorithm is also an approximate algorithm, meaning it is not guaranteed to give you that perfect result. And none of these algorithms are, except for brute force, which we're going to get to at the very end. But nonetheless, we are getting good answers, and we'll confirm in the last video when I get to brute force that to see if this is really the best answer that we can find. But let's go ahead and wrap it up. So that was the same answer, just it was the same circuit starting from F. And this reminds me of an important point, that the homework is a little bit confusing in how it asks for the solutions to this. What it will often say is run the nearest neighbor algorithm starting from E, but actually start from A, or something along those lines. But it's because when we run the repetitive nearest neighbor algorithm, we get a whole bunch of different answers, and the question is, well, which of these is the right answer? They're all the lowest weight, because reviewing back to the final step, choose the result with the least cost. Obviously, we want to spend the least amount of money. But which one do I choose? Well, technically, they're all this. That's the point. They're all the same answer, so they're arbitrary. They're arbitrary. But let's say if we return back to the original problem, um, let's say that um, in this traveling salesman problem, let's say that we actually lived in A, and we wanted to uh, take a bus between each of these locations and get back to our start, and spend the least amount of money. Now, of course, we're not going to use the actual option starting from A because that's more expensive. But what we could do is we could shift these circuits to start from A. Since these are the best answer I get from the nearest neighbor algorithm, I could reroute them starting from A, because ultimately I had that route, which was a circuit that looked something like this in black, and a circuit you can start from any point, because it is like a racetrack, or a NASCAR. Really, they're just going around in a circle. I mean, it's not a circle, it's a circuit. That's the difference. But you can start from any point in the circuit and it will still work. So basically, if I wanted to reroute the circuit, I would just start from A and follow along the same paths that we did in those answers. And they're all the same, which is why I'm saying they're not technically the same, but they really are for the context of the problem. And it does not matter which way you could go. You could go A, D, E, F, B, C, A, and follow along the black highlights. Or you could do A, C, B, F, E, D, A. Which, notice that those are the same circuits, but if you look at the letters, they're just in the reverse order, or palindromes. Um, but anyways, both of them have a net weight 54 as well, because it's the same thing. And that's kind of what the homework is asking when it says start from D, but then change it to A, because it's really the same answer, just shifted to starting from A instead. And occasionally I've noticed that the online homework might accept one but not the other, which is irritating. And if you run into that, just let me know and I'll fix it manually. But that will wrap up the repetitive nearest neighbor algorithm.